Like the aldol reaction, there's also an intramolecular variation of the Claisen condensation where you have two esters or a ketone and an ester in the same chain. Like the aldol reaction, this really only works well to form 5- and 6-membered rings. Here's an example where we have two esters in the same chain. It's symmetric, so it doesn't matter which one we choose to work with as the enolate. But what you want to do before you ever start is just highlight an enolate carbon and then count to the other carbonyl and see if that will give you a 5- or 6-membered ring. So here, that would be carbon 1, 2, 3, 4, 5. That will give us a 5-membered ring, so we would expect this reaction to work. If they're too far apart or too close together, the reaction won't take place. So for this, let's go ahead and draw the enolate. I'm going to put the negative charge here. And with these intramolecular cases, I find it's always easiest to number. And just number the atoms involved in the reaction to form the ring. So I'll start at the carbon with the negative charge and number out to the ester that we're reacting with. So instead of going through the full mechanism for this, we're going to take a shortcut. Just remember, this is a shortcut, not the true mechanism, where the negative charge will attack here and lose the O-ethyl group. So then we're left with a 5-membered ring. So draw your ring, number it. It's 1, 2, 3, 4, 5. And then let's draw in what we have. So coming off of carbon 1, I have the C double bond O, O-ethyl group. So C double bond O, OET. Then on carbon 5, I have the carbonyl. And that's the product for this reaction. Here's a version where we have a ketone and an ester. So find your enolizable positions of the ketone. It's here and here. From there, what you want to do is figure out which one will give you an ideal ring size, if any. Well, this enolizable position, if we count 1, 2, 3, 4, that would give us a 4-membered ring reacting with the ester. If we count from the other, we get 1, 2, 3, 4, 5, 6. That'll give us a 6-membered ring. So we want to form the enolate on this side. If we draw that, there's our negative charge. Here's the 6 carbons reacting. Again, we're going to use the shortcut just to predict the product. And we'll draw the 6-membered ring. Number your atoms. At carbon 2, we have a carbonyl. At carbon 6, we have a carbonyl. And that's the product. Anytime you're doing a Claisen reaction, you should have a 1,3-dicarbonyl in the product. If you don't, it might be an ester and a ketone, or it might be two ketones, but it needs to be 1,3-dicarbonyl. So 1, 2, 3. If they're not in that relationship, you've messed something up.